Okay, ladies and gentlemen, today we're going to learn about geometric probability, and it's very similar to binomial probability. And if you understood the notes on the calculator for the binom, geometric should go relatively easy. The only difference between a geometric probability is in our acronym, instead of bins, we use bits. And what does T stand for? It stands for wait time. We are waiting for our first success. So if a basketball player is at the free throw line, they're not shooting 10 baskets. We're wondering, how long are we going to have to wait until they make their first basket? That's the difference with geometric versus binomial. Everything else is still the same. The one thing that you'll need to know for geometric is the mean, and the mean is 1 over p. You don't need to know that previous formula because you do have your graphing calculator this year, and so I'm going to show you how to use that graphing calculator. Let's get going right away. Same thing as last time. As for binomial, we either have an x is equal to or we have an inequality, and we can use our calculator with the geometric distribution this time. If it's an equal to, we're jumping for joy. We do a PDF, it makes it nice and easy. If it's an inequality, we need to make sure that it's a less than or equal to every single time. So we need to manipulate it like we did last time so we can use our calculator and we can use that CDF. Let's get going. 6% of people have O negative blood. So you can imagine we're at a blood drive and they're testing your blood, okay? What is the probability that the first O negative person is the fourth person tested? So again, I want to write the probability statement. The first success is, ooh, baby, is the fourth person tested. This is jumping for joy. This is an equal to. So the probability of what's the story? The story is, hey, people are coming into a blood drive. We want to know that the fourth person is the first success. That means they are that O negative person. Because it's an equal to, it's nice and easy. This is a geometric PDF. How do I type this in my calculator? Let's go to our calculator now. I'm going to hit second vars. I'm going to go to geometric PDF. So I scrolled up. PDF is letter F on mine. My P stands for my probability, so 0.06 because 6%, we need to write it as a decimal. Fourth person is my success, so I'm going to put 4. And I'm going to go ahead and I'm going to paste. If you have the old calculator, you need to type in 0.06 first. That's your P, comma, your X value, 4. Close the parentheses off and hit enter. We get 0.05 is that probability. So geometric PDF, 0.06, there's my P, comma, X, that's my success, that's 4. And I get 0.05 as my final probability. Again, if you're watching from AP Stats, you need 3 or 4 decimal places there. And make sure to show your work, you put that P and that X there as well for the College Board. Okay, let's move on to part B. What is the probability that it will take at most 3 people to find the O negative? Now it is not is, it's an at most. That means we have an inequality. Just like we did for the binomial distribution, what I want you to do is start writing out numbers. So the first person that walks in, they could be O negative, or the second person, or the third person, or the fourth person, or the fifth, dot, 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 always when we're dealing with the geometric distribution. There is no end. Why did I go to 5? Well, I see a 3 right here, so I just want to couple over that just to make my point or get my point across, okay? Now what I want to do is I want to circle what I want. I want to know what's the probability that it will be at most 3 people to find the first O negative blood. That means it could be the first person, it could be the second person, or it could be the third person. At most is the probability that X is less than or equal to 3. That's perfect. That matches what we want for a CDF. We want a less than or equal to, so we're okay. I'm going to Control Z that one. I don't know what happened there. We're okay to proceed, so let's go up. And let's write out. We can do a geometric CDF here. Okay, let me show you where to find that again. So we're going to go to second vars. I'm going to scroll up. So second vars. I'm going to scroll. Oopsie, sorry about that, guys. Second vars. I'm going to scroll up to geometric CDF is right there. My P is 0.06. My x value is whatever I put in that inequality, okay? Whatever's in that inequality. That's why it's really important to write that inequality out like I have right there. And then I'm going to go ahead and I'm going to paste. I get 0.169, so I'm going to round that to 0.17, okay? 0.06, comma 3 equals 0.17. All right, ladies and gentlemen, again, if you have that older calculator, you need to actually type in what the P is, comma, what the X value is there. Let's go on to the next question. What is the probability that it will take at least 3 people to find the first O negative person? Again, we don't have an equal to. It says at least. That's an inequality. I want to write everything out. So I'm going to write out 1. It could be the first person, second person, third, fourth, fifth, dot, 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 always dot, dot, dot when it comes to the geometric distribution because there are no fixed number of trials. It's a wait time till our first success. What is the probability it takes at least 3 people to find the first O negative person? That means at least 3 could be the third person, the fourth person, the fifth person, or dot, dot, dot. Keep continuing. This is what I want. So the probability that X is greater than or equal to 3 is what I want. Well, unfortunately, that doesn't work. I can't use my calculator for that. I need it to be a less than or equal to if we scroll back or you look at your notes. So anytime this happens, just like the binomial distribution, whenever it's a greater than or equal to inequality, we need to do the complement rule, which means I need to do 1 minus the probability of what I don't want. This is what I want. This is what I don't want. So I'm going to do 1 minus the probability that X is less than or equal to 2. Now I have it set up for a CDF. I need it to be a less than or equal to. So I'm going to do 1 minus geometric CDF. Okay, 1 minus geometric CDF. Let me show you how to type that in. I'm going to go to second vars. Geometric CDF is right here. 0.06. Then what do I want? I want the 2 there for my X value. I always look at that inequality so I know what to write there. 2. That's why it's so important to write this out, okay? So important to write this out and this out. I'm going to go ahead, I'm going to paste. And you know what I forgot to do, guys? I forgot to do 1 minus that. That's okay. What I can do then is I can just do 1 minus my answer. And my final answer then 1 minus this geometric CDF right there is 0.8836. So 0.06, comma 2, 0.88. Okay, let's keep cruising. Let's go to the next one. What is the probability that it will take more than 5 people to find the first O negative person? Again, let's go ahead and because it's more than 5 people, let's go ahead, let's write out 0. Whoop, I don't need to do 0. 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. Why did I go to 7 this time when I didn't last time? Because this problem is asking about 5. So I always like to go a couple more than what the problem asks for. Okay, I'm going to circle what I want. I want more than 5 people. That means I want this area here. This is what I want. The probability that X is greater than or equal to 6. Well, it's a greater than or equal to. That means I need to do that complement rule, meaning I need to do 1 minus the probability of what I don't want. I don't want this stuff over here. Okay, I don't want it. So I'm going to write it out, 1 minus the probability that X is less than or equal to 5. That means I'm going to do 1 minus geometric CDF 0.06, comma 5. Let's go ahead, let's type that in our calculator. Woo! Let's not forget the 1 minus this time. 1 minus second vars geometric CDF 0.06, comma 5. Paste, enter, 0.73. Okay, 0.73. All right, the last problem, ladies and gentlemen, and I am going a little bit faster, so make sure you're stopping where you need to and rewatching, re-listening, or writing down questions when you need to. What is the probability that it will take less than 5 people to find the first O negative person? Okay, again, it's not an equal to, it says less than 5. I'm going to write things out. 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. Again, why did I go to 7? I like to go 2 more than what I see in the problem. Now, I want less than 5 people. Where is less than 5? Less than 5 is right here. Okay, less than 5 is right here. So what I want now is the probability that x is less than or equal to 4. That's less than 5. Well, I'm in luck. This matches with the CDF from above. Oops, I need to hit a Control Z, I think. This matches from what I see up above. I'll show you. I have an x is less than or equal to a number, so I'm good to go on that geometric CDF. Okay, so I go to my calculator, second vars. I scroll up, my CDF is right there, 0.06, and I need a 4 there because of my inequality. Again, just showing the importance of writing that inequality out or it will be confusing. And I get 0.22, okay, 0.22. So geometric CDF, right? That's 0.06, that's my P. And then I have a 4 equals 0.22. Final answer, you guys, way to go, we did it. Have a great day, guys.